In this video, we want to find the exact value of the following trig expressions without using a calculator. So in several videos, we've used the sum to product formulas or product to sum formulas to solve some problems, some involving an identity. In this case, we want exact values. So the first one's a product. And yes, you can do it other ways, but this is the more direct way, since we just went over those particular formulas, product to sum and sum to product. You can find the exact value of angles like 30, 60, 45, or angles in center position that have a reference angle of one of those. Of the quadrantal angles, you should be able to find exact values like 0 degrees or 90 degrees or 180 or 270 and so on. So for the first one, we have a product. Second one, we have a difference. So we have sine of A, cosine of B, and you can see that's equal to sine of the sum of the two angles plus sine of the difference of the two angles. So we'll set it up this way. This is going to equal to 1/2. You can see it's sine of an angle times the cosine of an angle. So this is the formula we want, sine of A, cosine of B. And this is 1/2, and then this is going to be the sine of the sum of the two angles, A and B. In this case, A is 195 and B 75. So we add those up. So we get 270. And then it's plus the sine of the difference of the two angles, 195 minus 75. That's 120. So this gives us 1/2. And again, 270 is a quadrantal angle. So standard position, it's right here. So we can find the function value, trig function value of any angle if we can find a point on the terminal side. This one's easy. I can just go down to 1. That point would be 0, -1. So the sine of this angle is just the y value over the distance to that point, which is 1 unit. We're talking about absolute value now, so that's 1. -1/1. So this is -1 plus, now we want the sine of 120. So it's going to be somewhere over here in quadrant 2. The reference angle here, this is 120 there, so this is 60 degrees. And since the terminal side lies in quadrant 2, sine is positive in quadrant 2, so here we know that the sine of 120 would be the same thing as a sine of 60 degrees. Those are your basic angles there. So this is the square root of 3. No calculator needed. Square root of 3/2. And this is basically your answer. You can just leave it in this form, 1/2. Rearrange it any way you want. I'm going to put the square root of 3/2 first. -1. You want to multiply it out here and write the square root of 3/4 minus 1/2. But this is basically your answer there. Now for the next one, we have the difference of sine of 255 and 15 degrees. So we use this formula. Sine of A minus sine of B equals to 2 times, and then just follow through. The angles in this case are A and B, so in this case A is 255 and sine is 15. So this is equal to twice the sine. Again, in this case we're going from a difference to a product. Twice the sine of the difference of the two angles. So that's 255 minus 15. That's 240, but then that's divided by 2. So this is 120. The next one is going to be the sine. You look at the formula there of the sum of the two angles. So that's 270, and that's divided by 2. So that's 135. And this is cosine here. And then we just compute these. This will be twice then. And then the sine of 120, that's in 120, again we did this a while ago, is in quadrant 2. The sine is positive in quadrant 2. The reference angle is 60 degrees, so the sine of 120 should be the same thing as the sine of 60 degrees, which we saw a while ago is the square root of 3 over 2. Now we want the cosine of 135. 135 is in the second quadrant. In the second quadrant, the cosine is negative because the x value is negative there. So this is going to be a negative. And then the cosine of 135 is the same thing. The reference angle is 45. The cosine of 45 degrees is 1 over the square root of 2, or the square root of 2 over 2. So we can cancel this 2 and say with this 2, and then square root of 3 times minus the square root of 2. This is minus the square root of 6. And that's over 2. And that's your answer. Thanks for watching. We'll see you next time.